So exposing your body to cold also has a lot of positive benefits. And I think most people I think it's been popularized, at least in the media, that cold exposure is like this hack that you can do to help you burn more fat. So I think that's probably what most people associate sitting in an ice bath or taking a cold shower with doing is, oh, I'm going to increase my metabolism, burn more fat. And there is truth to that, and that's probably the least. I'm interested in that, but I've never, I think burning the way to regulate your weight and your amount of fat you have and all this is actually through diet. I think diet's the best way.
No question.
Right. However, there are benefits. The hormetic part of this cold exposure is what's really important, and the reason that you burn more fat when you're cold actually has to do with mitochondrial biogenesis. So maybe I'll start explaining this and then I'll get into some of the other benefits with cold that I'm a little more interested in as well. But because when you're cold, when your body is cold, what it wants to do is get warm because it wants to basically stay alive. It doesn't want to die, right? And you don't want to get hypothermic. So there's a very profound response mechanism that occurs when you cool the body, and that is your body makes the production of a hormone and a neurotransmitter called norepinephrine. So it produces norepinephrine in the brain, which is involved in focus and attention. It also improves mood. It's often used to treat depression as well as ADHD. But in the body, when you make it, it acts as a hormone. It does a lot of things. It causes vasoconstriction, and the reason it does that is because your body is trying to conserve heat. So this is one of the ways your body goes, okay, I'm cold, I need to conserve heat, increases norepinephrine, and norepinephrine then causes vasoconstriction, which then you lose less heat. So you're basically conserving what you have. But the other thing that norepinephrine does is it's a signaling molecule to basically make more mitochondria. So it causes your body to make more mitochondria in your fat tissue, because your fat tissue, that's your reserve stores, that's your energy restore, that's where you have your reserves for energy. And your body wants to make energy because when you make energy, the byproduct of energy is heat. Your body goes, okay, time to ramp up fat metabolism because I need some of that heat to warm myself. So the way it does it is by increasing norepinephrine. Norepinephrine sends a signal to your fat cells, and your fat cells activate a gene called UCP1, uncoupling 1. Sorry for the jargon, but you probably have seen it, it's all over the popular media. UCP1, what that does is two things. One, it causes your mitochondria in your fat cells to make more mitochondria. And this is often referred to as browning fat. And the reason it's called browning fat is because if you take a fat cell and you look at it under a microscope, the more mitochondria it has, the browner color it looks, because the mitochondria are so dense and it gives it this brown sort of coloring.
It's actually what turns the difference between white meat and dark meat, as far as I understand.
Exactly.
Like chicken. So the dark meat would be more active muscle with more mitochondria. Exactly.
That's a great analogy. And so that's what it's doing to your fat. And there's twofold. Basically, there's a couple of benefits from that. The first benefit is you start burning fat. Your body starts to get fat and metabolize it to generate energy and heat, and it's doing that more because now you have more mitochondria to be able to do that. The second thing that's a benefit is that the reason why it does that is because it's preparing for the next time it's going to be exposed to cold. And so this is where the more times people are exposed to cold, the more mitochondria they make in their fat cells, and the more they can withstand the cold. And this is where Wim Hof comes in, because he has a lot of brown fat. He has a lot of mitochondria in his fat cells because he's been exposing himself to cold on a daily basis for decades. So he's now able to withstand the cold for a longer period because he can make more heat. So the more mitochondria you have in your fat, the more fat you're burning, the more heat you can make, the longer you can stay in the cold. And so that's sort of the science behind how you can actually stay in cold for a longer period of time. So that's a great benefit.
Now, when you expose yourself to heat, you make something that you referenced before earlier is heat shock protein. And my understanding is you also make heat shock proteins when you expose yourself to extreme cold. But you also there's a cold shock protein, which is known as RNA binding motif 3, or more shorterly called RBM3 for short. So why don't you expand on that, because I think it's an intriguing, another example of hormesis.
Yes, it is. Thank you for pointing that out. It's one of my pet topics that I enjoy, because when you are exposing yourself to the cold, you do increase heat shock proteins, because heat shock proteins are responsive to stress in general, thermal stress, but they are more robustly activated in the heat. And then there's a whole class of proteins called cold shock proteins. And one in particular that you mentioned, RBM3, is in the brain. And the really cool thing about RBM3 is that it's doing a very important function. When you're exposed to the cold, you actually degrade synapses, which are the connections between neurons. It's how your neurons are communicating with each other. But RBM3 completely regenerates them. So it regenerates all those synapses that were lost in the cold, and this has been shown in hibernating animals like bears and squirrels that hibernate, that they very, very robustly increase a cold shock protein. They activate it in their brain, and this regenerates lost synapses. And this really great study was published not long ago that showed that when you take a mouse and you genetically engineer it to get Alzheimer's disease or neurodegenerative disease, and then you expose it to the cold so that it's increasing RBM3, it delays the onset of the Alzheimer's disease. Even though they were genetically engineered to get Alzheimer's disease, they get it much, much later. So that's really cool. And it's also was shown to increase the number of synapses. So Alzheimer's disease, you actually lose synapses with, as you age, you lose more and more synapses. But the RBM3 was able to maintain those synapses. So obviously, we're not mice. A lot of work to be done. However, there has been some studies in human cells that have shown that human brain cells, that RBM3 does get activated when the brain cells are exposed to cold, and that the cold temperature change just needed to be around a degree and a half or something like that in Fahrenheit, which is also achievable in humans. So it's a very intriguing idea, and there needs to be more research done, but it still sort of raises this important question that it does exposing your body to cold, is there some sort of neuroprotective effect in your brain? Is it good for your brain? And I would argue that yes, it is. And, so in addition to the RBM3 and the cold shock protein, the norepinephrine in your brain also is very good. It's also an anti-inflammatory. It decreases inflammation in the brain and the body. Like I said, it's involved. It's involved in focus and attention, and also it improves what's called long-term potentiation, which is basically what happens when you have a synapse. Is it strengthens that connection between the two neurons. It makes it stronger so that you can remember something. Mm-hmm. So norepinephrine regulates that process, and so it's really kind of neat that cold. You can actually increase norepinephrine by twofold. Just getting in 40-degree water for 20 seconds, or getting in 57-degree water for a few minutes. So it's really easy to sort of get in a cold shower.
And it's less expensive than an antidepressant, and probably more effective. And at least some antidepressants, because there's certainly a great percentage of them are serotonin reuptake inhibitors. But there's some, especially the earlier ones, that focus on norepinephrine.
There's serotonin and norepinephrine reuptake inhibitors. I think those are sort of coming back now. The combination of the two, where they're both serotonin and norepinephrine, and also norepinephrine alleviates pain. Mm-hmm. Partly because it lowers inflammation. It decreases the production of TNF-alpha, a very potent cytokine, which I'm sure you've talked about in great detail. But it dramatically decreases that cytokine so that you're not activating all these immune cells. And inflammation causes pain. That's why a lot of anti-inflammatories, can help alleviate pain. But also humans that have had back pain have had norepinephrine injected into their spine, and that alleviates the pain as well. So there is sort of this analgesic effect that happens with norepinephrine as well, that I think has to do with the lowering of inflammation. And then in addition,
That's
Oh yeah.
exciting because we talk about pain a lot on our side, especially with this epidemic of heroin overdoses and secondarily believed to be related to the wide abuse of prescription painkillers. So, and most people are, I mean, pain needs to be taken care of. Ideally, you need a solution for it, but it's very rare where one ever recommends cold stressors to decrease the inflammation and improve the pain.
It really is rare, and I think that it's something that's some people are starting to find that it helps. I've talked to some people that have, said that it helps with their arthritis pain or their mother's arthritis pain or, something like that. I'm trying to get my mom to do it. It's always a challenge, but I think once a person experiences the benefit, they realize, wow, this is easy. This has not negative side effects, but positive side effects because it's a hormetic stressor. It's activating all these good response pathways that we have hardwired in us to help us deal with stress. So it causes us to be more resilient. I think that it's something, it makes you feel good. I mean, I challenge people, if you just wake up, tomorrow morning or sometime this week, and you just get in the shower, dial it down to cooler water, and sing, do whatever. Sometimes I sing and I say, this is good for my brain, something to help you to stay in that water, and just do it for a few minutes, as long as you can, and see how you feel afterwards. See how you feel. And I would think that you're going to feel really good because the norepinephrine that gets released it's an antidepressant. It makes you feel good. You feel good, and those effects last throughout the day. So, and I've dug a lot into the science behind this, but I've also experienced it firsthand. And in fact, anytime I'm doing something that's very anxiety provoking, if I'm going on a big show or something where I'm going to have a bunch of eyeballs looking at me and I get really nervous, I'll take a cold shower, and guess what? I perform better because I'm less anxious.
Interesting.
So it helps me. It does help me.
So I find personally that taking a deep breath and holding a breath and then exposing yourself to the stressor is helpful to transition, because typically within a few seconds, certainly 5, 10, 20 at the most, your body sort of adjusts to it and you adapt. So then you then you relax and then you're okay, and then you sort of you're adapted. And then
part of that adaptation has to do with, so I didn't get too technical about this because I don't want to lose people, but part of that adaptation has to do with the browning of your fat, it's basically called thermogenesis. Mm-hmm. And so because you immediately start making more mitochondria when you're exposed to the cold and your fat as a protective mechanism to not die because your body wants to generate heat, immediately start doing it. And what you'll notice is some people, the first time you're exposed to cold, there's two ways your body can generate the heat, or can increase metabolism to generate the heat. The one we talked about, and that is the browning of the fat. But the other way is non-shivering thermogenesis, which basically means that your muscles start to twitch, and your muscles twitching, that is an energetically costly thing that happens. So you have to burn energy for your muscles to twitch, and so you're making heat. But that's not very thermodynamically favorable. It's better to make more mitochondria and burn fat.
Sure.
So the first time you'll do that, you'll shiver, but if you expose yourself again, you adapt quickly, you start to make mitochondria, and then you can handle the cold, and so it becomes easier and easier to do, and that's really neat because it's part of the adaptation.
Yeah, I think it's called the uncoupling of the energy production, and there's certain ethnicities, like those from Africa, that are exposed to these high extreme temperatures, that have this uncoupling, and when they move to countries like this, they are liberating all this heat, and it's not very efficient. And some scientists believe that's one of the reasons why they generate a lot more reactive oxygen species. But it's because if you're using it, it's not a problem, but if you're not, it's a major problem. So that's one of the reasons why I have these increased risk of all these chronic degenerative diseases, because it's got this massive increase of reactive oxygen species and secondary free radicals.
Oh, interesting. Yeah, I did know that there are different people that have gene variations in the genes. The uncoupling is UCP1. Yeah, right. Exactly. UCP1. Yeah. So, but on the mitochondrial biogenesis topic, did you want to dive into the fact that it also increases mitochondrial biogenesis?
Oh, absolutely. One of my favorite areas is mitochondrial biogenesis.
Well, you mentioned the PGC1 alpha when we
Yes.
were first talking, and
Right. PGC. I love PGC1 alpha. My favorite, one of my
well, then you're going to love
favorite
the
signals.
cold because it increases PGC1 alpha
It's, and oh, that's right. You said that from your
in the muscle.
review that was probably the most potent stimulus of PGC1 alpha.
Yeah, it's one of the most
Wow.
potent stimulants, and the reason for that is because what do you think? If your body thinks it's going to die, so exercise obviously is a stress, but
Yes.
cold will kill you.
No. Yeah.
People
die from hypothermia all the time.
Right, it will kill you. And so your body, when you start to cool your body freaks out, and it says, I gotta gather all my troops. I gotta do everything I can to fight this war so that I stay alive. And so one of the ways it does that is by increasing mitochondria in multiple tissues. It also does it in the muscle. So you actually make more mitochondria in the muscle, and this happens through PGC1 alpha. So you're also making more mitochondria in muscle, which is really good for multiple reasons. Obviously, it helps, the more mitochondria you have, the more energy you can produce, the more muscle mass you can maintain. So these things are all very good. But I do think the cold itself is probably one of the most potent stimulators of mitochondrial biogenesis. Now, of course, this probably also largely depends on the temperature, the duration. I mean, so the longer I've done almost everything. I've jumped in the Pacific Ocean in the winter. I've done a cold shower. I've done ice baths. I've done whole body cryotherapy. I've done all those things, and they all make you feel really good. They all have the norepinephrine. If you're getting that norepinephrine, then I think that's a good way to gauge whether or not you're getting that cold shock response.
Sure. Now, just like tangent with exercise, because it is a caution, not so much for cardiovascular, but certainly for strengthening exercise. When you exercise, you generate these signals, these reactive oxygen species that actually produce, especially for resistance training, increased muscle mass. So if you have a cold exposure within the first hour, you're going to suppress that, which is very unwise to do. So you want to not have these cold exposures immediately after strength training. Potentially cardio, I think it's okay, maybe even helpful. But I'm wondering if you have the exposure not around the strength training, sort of independent of that, if that, because of the massive stimulus to mitochondrial biogenesis, PGC1 alpha, if that will help increase muscle growth.
So thank you for pointing that out, because it's a very important point. Whereas doing the sauna after exercise actually can increase muscle mass, which is why saunas are in gyms.
It helps detox too.
Yeah, it does. Yeah, it helps you sweat out BPA, the phthalates, and you can sweat out mercury and other heavy metals and all that stuff. But you're not going to prevent the signaling molecules that are generated from exercise from doing their positive thing if you get in the sauna. But if you get in the cold immediately after exercise, and this is what's important to understand, is that, like we talked about, exercise is a stress. It's stressful in the body. You're making a reactive oxygen species. You're generating inflammation, but that's a good thing because it's a short burst of it. You want it. And this happens within an hour, and this has been shown in multiple studies. There's an hour time frame from the time you're exercising from the time you stop exercising. An hour later, within that hour is the peak pro-inflammation. It's that stressful period. But then as soon as an hour hits, the stress response kicks in, and you start to have an anti-inflammatory, you start to have an antioxidant response from activating all these genes. And so what happens, because the cold also is causing an anti-inflammatory response, it's important that you don't get that anti-inflammatory response too soon, because you need some of that inflammation. You want that inflammation to happen to get the anti-inflammatory response. And that's important for the strength training and the reason that is important for strength training is because the inflammation that you generate during the strength training is part of the mechanism for making more proteins in the skeletal muscle. And if you blunt that, then you're gonna blunt the effects of the strength training, and that has been shown before. The question is then, can you do it an hour or 2 hours later? And the other studies have shown, yes, that you can do cold exposure, cold water immersion, and get actually some performance enhancements even from doing Those knee extensors, is that what they're called? I always forget. Leg extensors, yeah, leg extensions.
Extensions, yeah. So the other, I think that the hour window is a really important observation, and probably the window where you want to therapeutically use nutrients, specifically amino acids, to also enhance muscle building, and those would be the branch chain amino acids, leucine, isoleucine, and valine, but primarily leucine, which is the most potent stimulus for muscle growth. So I'm not a big fan of using them. I'd rather use them in food in a high-quality whey product. And I do use them personally. So after strength training, within the first hour, usually typically half hour, I'll have a fairly significant dose of these branch chain amino acids, leucine primarily, through a high-quality whey product. So I think it's a good window. That's the only time I use them. I think if you use them otherwise, they're potentially dangerous, and you actually can activate mTOR, which will inhibit mitochondrial biogenesis.
Yes.
But it's all about timing. Timing is key.
That's interesting. I know that you can, there's a 24-hour time period that you can take up branch chain amino acids after exercise, but you're right that
right after it's going to be better.
Right after
the same reason why cold. I mean, you've empirically, anecdotally proved it with those cold observations.
Yeah.
So that's the window. That is the window.
Yes, and in terms of the endurance, it doesn't seem to be as important. However, for whatever reason, all the scientists that are doing research looking at the effects of cold water immersion or cryotherapy on endurance athletes, they're always waiting an hour for some reason, which is very strange, except for the ones that are doing it between two bouts of exercise. So if you're doing a swim and then you're doing a bike ride or a run, it's kind of like, two bouts of exercise, it can improve your performance on the second bout, which makes sense.
Sure.
But
all right, so there is more information, obviously, in your reports, and we'll get into how to retrieve those again. But one of the reasons I really enjoy dialoguing with you on these topics is not because you're just so smart, but you're able to actually digest it and synthesize it and give it a practical perspective. So I'd like your comments on a principle that we strongly advocate, which is to listen to your body, to respect what signals it's giving to you. And this is a fine balance, and maybe there is no answer, but I would appreciate your opinion. Because this is distress, a form of distress, and it's uncomfortable. And of course, you mentioned we need to explore those areas. So what would you recommend to explore that discomfort? Because at some point it actually can be damaging. And you need to honor what your body's telling you to back off. So, I mean, how do you put your toe in the water, so to speak, and begin to reap some of these hormetic benefits, which are truly profound and virtually free in most cases, if you understand how to use them? So do you have any advice on how to reconcile that potential conflict?
Yeah. Well, I mean, the way that I like to think about it, first of all, I think it's important to mention that people that have any sort of medical condition that's, that you need to talk to your doctor, obviously, I hate saying that because, for obvious reasons, but, these are stressors, and in particular, the cold stress, whereas the sauna can be very beneficial for people with different cardiovascular related diseases because of the vasodilation and the whole mechanisms of increasing the blood flow and helping with blood pressure and all those things. Cold is a little different because cold is causing vasoconstriction very acutely, very acutely. But if you have some sort of heart condition, that's something that does need to be considered because that can be potentially dangerous. So that is something that I would warn people with heart conditions. Maybe a quick cold shower is okay, but don't get in an ice bath or do anything really extreme. Obviously, maybe even talk to your doctor. But with that said, in general, it's really, really good to listen to your body. Like if you need to recover from this stress, otherwise it's not going to be beneficial. If you're exercising all day every day, you're gonna die. You can't constantly keep stretching your body without a recovery period, and it's part of the reason why sleep is so important. You're recovering, you're repairing all this damage that you've generated throughout the day. But if you're feeling, and I tend to push things to the extreme. I'm getting better with that now, but I have experienced, myself when I've sat in an ice bath for several minutes, and I started to get lightheaded. And it's like, this is not, I shouldn't be feeling lightheaded. that's enough. I need to get out. Or the same with the sauna. You start to feel, feeling uncomfortable is good. You want to push past that, a little bit past that comfort, and feel a little uncomfortable. It's important for some of the hormetic benefits, but you don't want to faint. Never bring alcohol in the sauna, ever. Don't drink and get in the sauna. Don't drink before you get in the sauna. It's not good. Not good. But you do need to listen to yourself, and you don't want to go overboard. And I think for me, when I start to, if I feel faint or lightheaded or anything sort of weird, that's it. That's enough. Done. So you need to really be careful and just listen to your body. Listen to your body.
Great, that helps, because that information actually is not in your report. So let's get back to those reports again. It's on your site, foundmyfitness.com. No hyphens, all one word. Found My Fitness, real easy to find. I listen to all your podcasts regularly because there's just so much. It's such a pleasure to me. I mean, I really enjoy. I just am a passionate learner. I really.
You're a science geek.
Yeah, I get great insights from your. So if you like health, I mean, you're crazy not to subscribe to your channel, and then you've got lots of great free reports that really, especially with respect to our conversation, because it was relatively short. There's literally, like I said, at least a half to three-quarters of a full book for free if you download both of these reports. There's no charge for them, so if you found this topic intriguing, and it's hard to imagine that you wouldn't. I mean, there's just a lot of solid information here, and it's not expensive stuff. It's just simple strategies to keep you healthy, which is why I love it. It's just basic stuff.
Yeah.
And
yes, the cold stuff that we talked about today, the cold report that I put out is 20 pages, and it's a lot of good information.
Yeah,
it's a lot of good information. It is free, but I ask people to sign up for my newsletter. But you're going to get more good information. So
why wouldn't you want to? Why wouldn't you want to do that? And you're not, you don't sell products and stuff, so it's like, it's just solid science related to health. And obviously, if you listen this far, you know what type of information and the way you're going to convey it. So it's no different on it's on your site. It's the same information. So I strongly recommend that, and I really thank you for the time and really the insights and the information. I'm sure it's going to help a lot of people.